Hi, I'm Rich with insideHPC. We're here at SC12 in Salt Lake City. We're here at the Numerical Algorithms booth, also known as NAG, and I'm here with David. David, let's just start at the beginning. Who is NAG and who do you help?
Okay, we help all sorts of people by providing a range of numerical code that can be used in many different applications. We've been doing it for about 40 years, and we specialize in complex, accurate mathematical code for all sorts of areas.
So you guys are kind of the go-to guys. When you want something to scale at ultra scale, it seems like that's where I'm always seeing your name. Is that an accurate description?
That's true. In many ways, we're the de facto standard for numerical code across many industries these days.
Well, terrific. So I wanted to ask you about, this week we had a big announcement, the Intel Xeon Phi, this coprocessor. What do you got going in that space at NAG?
Okay. Well, we've been working with Intel for quite a long time on this project and others. For the Phi, we've had the prototype boards for about a year now in-house, and we've been looking at porting our classic library code to that Phi. And for example, here we've moved one of our correlation routines onto the Phi, and we have a quick demonstration here.
Okay, cool.
If I hit the start on this and then talk through it while it's going, we've got two halves of the rectangle here. The Phi has already produced results, while at the same time we've started the routine on a standard set of CPUs, in fact 8 cores of the Sandy Bridge processor. And what this shows is that while the Phi returns stuff in 2.3 seconds, exactly the same routine running on the standard processors took 12 seconds to do that.
Yeah.
So this is research we've been doing and running our routines on the Phi and showing the great performance improvements there.
So are you seeing good scaling? I mean, we're getting good speed up. You hook this thing up, and with your help,
we've found some good stuff. So this is sort of the peak performance we've got amongst our routines at this stage, and we also found it very easy to move our code onto the Phi platform. Our challenge and our skill is in tuning these routines to really get the best performance and selecting the best algorithms to port across to many core systems.
Yeah. So let's talk about that, because it seems like it's easy to get to port a code to run in this environment, but the next step, that optimization, is that where the heavy lifting comes in?
Yeah, that's part of it, and there's a bit beyond that, almost the research stage, which is finding the best algorithms, the best mathematics that will work well on these many core systems. We're lucky we've got lots of experience there at big HPC systems as well, so moving those down onto single coprocessors with many cores and with different memory distributions is where our strength lies.